State how hydrogen occur in free state. Name 3 compounds containing hydrogen in combined state. So in free state, hydrogen occurs in Earth's crust, atmosphere and in volcanic gases. It is also present in interior of the sun and it is converting into heat and light energy. Now comes combined state. Now what is the meaning of combined state? That when hydrogen is along with another element, for example, hydrogen is combined with two other atoms of oxygen and it is making H2O. So this form is known as combined state. Free state means it is in its molecular state. So this is free state where hydrogen alone in its molecular form it is existing. So it is existing in the Earth's crust, in atmosphere, in volcanic gas and in the interior of the star. So this is all about free state. Now combined state means it is along with another element, it is chemically attached with another atoms. So for example, water, molecular formula is H2O. So 1/9 mass of water is hydrogen. It is in the water in combined state. Then comes acid. Majority of all the acid, for example, hydrochloric acid, sulfuric acid, H2SO4 and nitric acid, HNO3. These three are the main acid in our chemistry, and in all of this acid the hydrogen is there in combined state. Then comes organic compound. Organic compounds we can make with carbon, hydrogen, oxygen, nitrogen and some other elements, but the key elements are carbon and hydrogen which are making organic compound. So hydrogen is one of the key element in organic compound. Then comes protein. So protein molecules also contains carbon, hydrogen and nitrogen. It is one of the key element of protein. In plants and animals, tissue of plants and animals are made up of hydrogen. So in combined state, if you want to write a molecular formula, then you can write all this, that H2O in water in all these three acids. And for organic compound, we can write C6H12O6 glucose. So all these compounds contain combined form of hydrogen. From zinc, how would you obtain hydrogen using steam, dilute acid and an alkali? Give balanced equation for all. Which metal won't react with above reactants? So first question, that starting from zinc, how would you obtain hydrogen using steam, dilute acid and alkali? This is our metal reactivity series. So zinc, iron, lead, hydrogen, copper, mercury, silver, platinum and gold. All these metals come after zinc. So let us start with zinc and we are taking first steam. So what will be the reaction of zinc along with the steam? So steam is H2O only. So zinc along with the H2O we will get. Now zinc is positive element. It will combine with water. So we will get ZnO, zinc oxide plus hydrogen gas. Now all other metals which are coming after zinc, they will not react with steam because their reactivity is less. They are less reactive compared to zinc, so they cannot react with steam. Then second is a dilute acid. Our reaction of zinc along with dilute acid, I am taking HCl, a diluted one. So I am mentioning here the dilute acid, DIL. So we will get here ZnCl2. How we can make a molecular formula? Its combining capacity is 2, Cl's combining capacity is 1. Via crisscross method we will get ZnCl2 and this is our molecular formula of zinc chloride. And then we will get H2 gas liberated over here. We will get hydrogen gas. But as we can see here, Cl and H2 both are 2 towards product side. So we have to add here 2 for the balancing of equation. So in this reaction we will get zinc chloride. If you have any doubt regarding molecular formula, please watch my video based on how to write molecular formula for chemical compound. Rest all metals starting from Fe till Au, gold, they cannot react with dilute acid. The last one is an alkali. So zinc along with alkali, as an alkali I am taking NaOH, that is sodium hydroxide, and we will get, so towards product I will get Na2ZnO2. and this is sodium zincate. Along with that, I will get hydrogen gas. To balance the equation, here towards product side, sodium and oxygen both are twice. So here I have to add 2 at front of the NaOH to balance the equation. Now name of this product is sodium zincate. All metals starting from Fe till Au, they cannot react with alkali. Our question is, hydrogen is obtained by electrolysis of acidified water. Answer the following pertaining to the preparation of hydrogen by electrolysis. If you have any doubt regarding this electrolysis process, please watch my video based on electrolysis of acidified water. Our first question is the meaning of term electrolysis and electrolyte. First of all, electrolysis is a process, and electrolyte is a solution of ions or a chemical compound which will pass and which will carry the electricity in process of electrolysis. So these two things are completely different. Let us understand what is the process of electrolysis. So electrolysis is the process of decomposition of chemical compound. Now what is the meaning of decomposition? With the help of chemical reaction, when we are breaking any compound, for example NaOH is there, then we are breaking it, for example Na plus, and we will get OH minus, or we will get HCl. So when we will break this, H plus plus Cl minus. So this chemical decomposition when we are doing with the help of electricity. In a fused means it is a molten state. When we are adding some drops of water into a chemical substance, that will be its molten state or fused state. Paste-like form is known as fused. Or solution. Solution, we know that this compounds we will dissolve it into the water. So that will make a solution of this compound. By passage of electricity and will result in dissociation of chemical compounds into ions. So these are the chemical compounds, and these are the dissociation form of chemical compounds, and they are in the form of ions when they are bearing the charge. So they are ions, and this happens via passage of electricity. So this ion will discharge. Now once this ion will be separated into the solution, they will go to respective electrodes and there they will get discharge. Meaning of discharge, dis and charge, they are removing their charge. Whatever charge they are possessing in their ion state, they are removing their charge, and Na plus will become Na metal, sodium metal, and H plus will become hydrogen gas. It will converting into its molecular state. So they are discharging, they are removing their charge at their respective electrodes. So this whole process is known as electrolysis. Chemical compound we are taking, those chemical compound will dissociate, they are forming ions, then they are going to respective electrodes, and then they are getting discharge. This happens with the help of electricity. So this process is known as electrolysis. Electrolyte. Now electrolyte is a chemical compound which is in molten or solution state. Again, molten means paste-like structure, and solution means chemical compound along with the water. When chemical compound will dissolve in the water, it will come in its solution state. Can conduct electricity and undergo chemical decomposition. As I have shown you earlier, HCl will decompose into H plus and Cl minus. And this happens via chemical reaction. So it is chemical decomposition due to passage of electricity. Now this chemical reaction will not happen by itself. Once we are passing the electricity, this chemical compound will get decomposed into its ions. So this is an electrolyte. Question B. Name the electrode through which the current enters the electrolyte. Now current enters from the positive electrode, so it is anode. Current direction is always from positive to negative, and then the circuit will be completed and current leaves at cathode, and cathode is our negative electrode. Now hydrogen will be liberated at cathode. As we can see it into the figure, hydrogen gas will be liberated at cathode. Now why is it so? Because hydrogen is positive element. It will get attracted towards the negative electrode. Our negative electrode is cathode. So H plus is not stable, so it will get converted into its molecular form. Once it will get discharged, so hydrogen-hydrogen bond will form and we will get hydrogen gas at cathode electrode. Our question is, in the laboratory preparation of hydrogen, zinc and dilute hydrochloric acid, state a reason for all this following. So first, A question is addition of traces of copper 2 sulfate to the reaction medium. While we are doing this reaction, our reactants are zinc and hydrochloric acid, and as a product we will get zinc chloride and hydrogen gas. Now while we are performing this reaction, we are adding copper 2 sulfate along with dilute hydrochloric acid. The traces means 1 or 2 drop of copper 2 sulfate we are adding into that. Now reason for that is to enhance the rate of reaction. This reaction is slow, so to enhance the speed of reaction we are adding copper 2 sulfate to the reaction medium. Our second reason, collecting the hydrogen gas by downward displacement of water. Now what is the meaning of downward displacement of water? That this is our water bath and into that this is our gas jar. So here the water is there, as we can see into the figure, and into the gas jar also the water will be there. As the hydrogen will come from the tube, the hydrogen will come at the top and water slowly will displace towards downward, because hydrogen is lighter than water. Hydrogen is taking place towards upward and it is pushing the water down. So water will come to the water bath. So this is known as downward displacement of water. When process will start, the water will be till here. As the hydrogen will come from the reaction as a product, it is taking the place of water and slowly water will go down. So it is downward and it is displacing the water. So that means it is downward displacement of water. Now the question is, we are not collecting hydrogen along with the air and we are collecting it along with the water. What is the reason? Because hydrogen is slightly soluble in the water, we will not get less quantity of the hydrogen because of the dissolution, so we are collecting it over the water. Now what is the reason why we are not collecting along with the air? Because air and hydrogen mixture is explosive and it is not advisable to mix pure hydrogen along with the air. So we are not collecting hydrogen along with the air and we are collecting hydrogen along with the water. Now see, having the end of thistle funnel dip below the level of acid into the flask. As we can see it here, thistle funnel's end is into the acid and not over here into the air or outside of the acid. What is the reason for that? So that the hydrogen gas will not escape through thistle funnel. Now imagine a situation where thistle funnel's end is over here. So whatever hydrogen bubbles we are getting, those hydrogen bubbles may escape through thistle funnel. So thistle funnel's end should be dipped inside the hydrochloric acid. So hydrogen's quantity will not be less and it will not escape through thistle funnel. Our question is, in the industrial method of preparation of hydrogen by Bosch process. So we are talking about Bosch process. Give balanced equation for the first two main steps in the production of hydrogen. So here we have to write two main reactions. Then the reason for use of addition of promoter along with the catalyst in final step. And the next question is the name of the solution which absorbs the unreacted carbon monoxide. If you have any doubt regarding the Bosch process of manufacturing hydrogen, then please watch my video based on Bosch process and then come back to this question. So first question is balanced equation for first two main steps in production of hydrogen. So here our reaction, the first reaction is when coke is reacting with the steam. Now this is water at the temperature of 1000 degrees Celsius. We will get carbon monoxide plus hydrogen mixture and it is known as water gas. Now these two are in a combined state. I have received many comments saying that once we are getting the hydrogen at this step, why can't we take that hydrogen? This is not a molecular hydrogen. This is not in a free state. It is combined with the CO, and it is this combination, that CO plus H2, is known as water gas, and hydrogen is not free in this step. And minus delta means this reaction is endothermic reaction which will absorb the heat in this step. So this is endothermic reaction. As we can see, minus delta is here, and this reaction happens at 1000 degrees Celsius. Now our second step. In this again we are taking that mixture of water gas and some excess steam we are taking. This reaction we are performing at 450 degrees Celsius along with the catalyst, that is iron oxide. This Fe2O3 is iron 3 oxide. Iron 3 oxide is a catalyst, and in the presence of catalyst and 450 degrees Celsius, we will get carbon dioxide and hydrogen gas, and some heat will be liberated out. So this reaction is exothermic reaction. So to start the process, we have to give heat, but at the end of the reaction, we will get some heat liberated out. So that's why this is exothermic process. Whatever heat we are giving, more than that we are getting at the end. So that's why it is exothermic process. Now along with Fe2O3, iron 3 oxide, we are also adding chromic oxide, and that is promoter. So chromic oxide is Cr2O3. We are adding this as an promoter. Promoter will enhance the efficiency of catalyst. So catalyst's efficiency will increase and it will perform better in the presence of chromic oxide. Question B. The reason for use of addition of promoter to the catalyst in the final step. Our catalyst is iron 3 oxide, and along with that we are adding promoter. Now our promoter is chromic oxide, so it is Cr2O3. It is chromic oxide and we are adding this to enhances the efficiency of catalyst. So catalyst will perform better in presence of chromic oxide. That's why we are adding promoter at the final step. Question C. Name the solution which absorbs the unreacted carbon monoxide. Now we have to remove carbon dioxide and carbon monoxide at the final step to get the pure hydrogen gas. So to remove carbon monoxide, we are using ammoniacal cuprous chloride solution. Now cuprous chloride is CuCl, where Cu's valency is +1. So that's why CuCl both are having 1,1 valency. Via crisscross method we will get CuCl, that is cuprous chloride. When it is CuCl2, it is copper chloride. This is along with the variable valency, so it is +1, it is cuprous chloride. Now ammoniacal means we are adding some ammonia, and so it is known as ammoniacal cuprous chloride. Our question is, state the following pertaining to physical properties of hydrogen. So we have to list here physical properties of hydrogen with respect to color and odor, solubility in water, and third one is effect on moist blue litmus paper. So first, color and odor. Hydrogen is colorless and odorless gas. Hydrogen is slightly soluble in the water, and hydrogen's effect on moist blue litmus paper is none. That means blue litmus paper will remain blue. Draw neat label diagrams for two different experiments to prove that hydrogen is lighter than air. That means we have to show that hydrogen can go up in the air, or hydrogen can displace air and it can take the place of air above air. So these are the two experiments. First is this and second is this. In first experiment, this is the same experiment where we are producing hydrogen gas via laboratory method. So these are the zinc granules. In HCl, this is a Thissell funnel. Via Thissell funnel, adding HCl dropwise into this. Hydrogen bubbles are going through gas delivery tube and it is going in a soap solution. This is a soap solution. So whatever bubbles of hydrogen will come, they'll go up in the air. Once they'll go up in the air, it will show us that hydrogen is lighter in the air. That's why it is going up in the air. So this process is similar to the laboratory preparation of hydrogen via zinc and hydrochloric acid. Now our second experiment. In this, in one test tube, there are two test tubes. This is a first test tube and this is a second test tube. In first test tube we are taking hydrogen and in second test tube we are taking air. Now we are placing the test tube which is filled with the air above the test tube of the hydrogen, just as shown in the figure like this, and after some time we are adding glowing sphincter into the test tube and we will see that it is sparkling at the mouth of the first test tube. That means the hydrogen has traveled all the way till the upper test tube because hydrogen is lighter than air. So once we are placing the test tube on one above the other, the hydrogen will take the place of air and it will go to the upper test tube. Here I have shown you the blue color, where in first situation the blue color is in below test tube, in second situation the blue color is in the upper test tube. So these two experiments show us that hydrogen is lighter than air. Our question is, starting from hydrogen gas, how would you obtain neutral liquid? So neutral liquid is water. A basic gas is ammonia, and a metal by reduction of its heated oxide, that we have to find out from activity or reactivity series of the metal. First, we have to produce water from the hydrogen. So we are taking hydrogen here, along with that we are taking oxygen and we will get water molecule, that is H2O. Now we have to balance the equation. Oxygen is 2 towards reactant side and 1 towards product side. So we are adding 2 at the front of the product. So we have to add here 2 towards reactant side. Now our equation is balanced and we got here water as a product. Now another equation we have to write, that is we have to manufacture ammonia from the hydrogen gas. Now molecular formula of ammonia is NH3. So nitrogen gas and hydrogen gas we are taking, and there are some reaction condition and we will get NH3 as a product. Now we have to first balance this. So hydrogen is 3 towards product side and 2 towards reactant side. So we are adding 2 towards product side and here 3. So now our equation is balanced, 2 nitrogen and 6 hydrogen towards reactant side and product side. Now the conditions for the reaction is, we are doing this reaction at 400 to 500 degrees Celsius. We are using temperature that is 200 to 900 atmosphere, and we are using catalyst, that is iron. So iron we are using as catalyst. So all this condition we are mentioning on the arrow. Then see, a metal by reduction of its heated oxide. That means the metal is along with its oxide. Once we are reducing it, we will get that metal. Metal formed is above iron in activity series. Whatever metal is forming over here, that means whatever metal we are getting towards product side is above iron. Now this is our reactivity series, this is iron, and above iron is zinc. That means we are getting zinc towards product side. Now metal by reduction. So this reaction has to be reduction reaction of its heated oxide. So zinc is producing from its own oxide. So it is ZnO. We are using zinc oxide, along with that hydrogen gas will be there. So we will get, as a reduction product, we will get zinc metal, and along with that we will get water. So H2O. And this is a reduction reaction. Why this is reduction reaction? Because in reduction the oxygen will get removed. This is the reduction reaction in which oxygen is removed, hydrogen is added, or electron is added. any one of this will happen, then it is reduction reaction. So what is happening over here? Here oxygen is getting removed from the product. From ZnO it is becoming zinc. Oxygen is removed. So this is reduction reaction. Is using a burning candle and a jar of hydrogen, how would you prove experimentally that hydrogen is a combustible gas? First, and hydrogen does not support combustion. So this experiment we can show that into this cylindrical jar the hydrogen gas is filled. Once we are keeping on top of the candle, burning candle, it will start burning. So this proves the first one, that hydrogen is a combustible gas. But once we are placing completely on the candle will extinguish, and it shows that hydrogen do not support combustion. So here in second situation we can prove that hydrogen does not support combustion because candle got extinguished. Our question is, state a reason why when hydrogen is passed over heated copper oxide, the resultant product formed differs in color from the original reactant. So when copper oxide along with the hydrogen, so copper oxide is CuO when it is reacting with hydrogen. So in this case we are getting Cu plus H2O. So this is a reduction reaction. As copper oxide is becoming copper, there is a removal of oxygen. So this is reduction reaction. Oxide is converting into copper, and this is a reduction reaction. Copper oxide is black in color. But when it is converting into copper, the copper's color is reddish brown color. Reaction will get completed. The black color substance will get converted into reddish brown color substance, in which the copper oxide is converting into copper. Our question is, with reference to the use of hydrogen, give reason for the following. First reason is hydrogen is generally not used in air balloon. So the answer is hydrogen is highly inflammable gas. So we are not using it into the air balloon, which can be dangerous. So nowadays the hydrogen has been replaced with helium gas, which is inert gas. Second, a mixture of hydrogen and oxygen on burning find application is welding and in cutting metal. Now in welding and in cutting metal we require very high temperature. When we are mixing hydrogen and oxygen, it is generating oxyhydrogen flame, and this flame can reach up to 2800 degrees Celsius. So we can use this high temperature for the welding and cutting metal. C. Reaction of hydrogen with nitrogen under specific condition find industrial utility. When the reaction with nitrogen and hydrogen will happen, we will get the ammonia, that is NH3, and this ammonia has a wide variety of uses in the industry, as it is used in fertilizer, nitric acid, explosive, and etc. So reaction of hydrogen with nitrogen under specific condition. Why it is written here that specific condition? Because this reaction happens at 400 to 500 degrees Celsius. We require 200 to 900 atmospheric pressure, and we also require catalyst, and that is iron. So all these conditions are necessary for this reaction. So it is mentioned here that under specific condition. Give a test to differentiate between two gas jar, one containing pure hydrogen and other hydrogen air mixture. So two simple tests are there. For the pure hydrogen, it burns quietly into the air with pale blue flame forming a water. So when hydrogen will burn in air, the reaction is going to be H2 plus O2, and we will get H2O. So it is forming a water over here. So this is a confirmatory test of pure hydrogen, that it burns quietly in the air. But when the hydrogen air mixture is there, it burns with characteristic popping sound. When hydrogen is along with the air, so it generates popping sound while it is burning. The question is, with reference to oxidation reduction reaction, complete the statement given by filling the blanks with only words, that is addition and removal. Now our first Question is, oxidation is a chemical reaction involving of oxygen. So first of all, let us understand what is oxidation. Oxidation is a reaction. Either of this can happen. First, addition of oxygen. Second, removal of hydrogen. And third, removal of electron. That means if it is Cu plus, it is becoming Cu plus 2. So there is a removal of electron over here. And that's why this is termed as oxidation reaction. Zinc will become zinc oxide, then that is oxidation. Removal of hydrogen means water molecule. If the oxygen is forming, then that is removal of hydrogen. That is also termed as oxidation reaction. Now here involving of oxygen. So that is addition of oxygen. Oxygen will be always added in oxidation. Addition of oxygen to a substance, or with respect to hydrogen, it is removal. Removal of hydrogen from a substance. Now second, so complete opposite thing will happen in reduction, that removal of oxygen, addition of hydrogen and addition of electron. Either of this thing will happen, then it is termed as reduction. So reduction on other hand involves with respect to hydrogen, that is addition. So addition of hydrogen is termed as reduction, or with respect to oxygen it is removal. So removal of oxygen is termed as reduction. Our question is, with a reference to equation Cl2 plus H2S gives us 2HCl plus sulfur pertaining to redox reaction. What is a redox reaction? In the reaction when oxidation and reduction both will happen, that is termed as redox reaction. Select the correct answer in each case. This is the difference of oxidation and reduction. In oxidation, there is addition of oxygen and removal of hydrogen. In reduction, there is addition of hydrogen and removal of oxygen. These both are quite opposite to each other. So now let us see here. We have to focus on hydrogen and oxygen whenever we are finding out oxidation or reduction reaction. So here hydrogen is there, and here also hydrogen is there. But hydrogen is there along with sulfur, where here the hydrogen has removed from the sulfur. So hydrogen is being removed from the sulfur, so it is removal of hydrogen. So this is oxidation reaction. That from H2S to sulfur is oxidation reaction. Chlorine is alone, and towards the product side, the hydrogen is along with that. So there is an addition of hydrogen. So chlorine is becoming HCl. So it is addition of hydrogen. So this is reduction. First one, chlorine is oxidized, reduced to HCl. So chlorine is converting into HCl. As we can see here, hydrogen is being added. So it is reduction. So we can say that chlorine is reduced to HCl. So it is not oxidized, it is reduced to HCl. Hydrogen sulfide, that is H2S, is oxidized or reduced to sulfur since the reaction involves addition or removal of hydrogen. So what is happening here? Addition or removal of hydrogen? It is removal of hydrogen. It is removal of hydrogen. Now, when removal of hydrogen is there, what is this removal of hydrogen? It is oxidation. So this is oxidized. This is oxidation reaction, and sulfur is being oxidized over here, not reduced. It is being oxidized over here. So reaction is oxidation and sulfur is being oxidized. Chlorine acts as an oxidizing reducing agent. Now understand this very carefully. Chlorine is there, and at the product side it is along with the hydrogen. So chlorine is being reduced here. That this is along with the hydrogen. So it is being reduced here. Why? Because it is along with the hydrogen. It is being reduced, so hydrogen is along with that, but in turn it is helping sulfur to get rid of hydrogen. So it is helping in oxidation. So that's why the agent is oxidizing agent, because it is helping in oxidation. whatever hydrogen is removed from the H2S. From H2S it is becoming S, and from chlorine it is becoming HCl. So this hydrogen has gone to chlorine. So chlorine is helping sulfur in oxidation. That's why it is oxidizing agent. If you have any doubt regarding oxidation, reduction, oxidizing agent and reducing reagent, then please watch my video based on oxidation reduction.